Hi everyone, welcome to another linear algebra tutorial. In this tutorial, we'll be learning how to find the transpose of a matrix. So, what exactly is transpose of a matrix? So far we have already learned what is a matrix. So, for any matrix, the transpose of a matrix is a matrix whose columns are the rows of the original matrix. Let's go into details of the following examples where we will be learning how to transpose a matrix. So now we are given these four matrices. As you can see, the four matrices are here. So let's work on the first matrix. So you'll notice that this matrix has 2 rows and 3 columns. Now to transpose it is this. So what do we see here? We can see that now the columns of the transpose matrix are the rows of the original matrix, which means that the elements of the matrix in row 1, which is 1, 2, and 3, becomes the columns of the transpose matrix, which is 1, 2, and 3. So 1, 2, and 3 becomes 1, 2, and 3. And 4, 5, and 6, which is on the second row, becomes on the second column, which is 4, 5, and 6. And as you can see, the dimensions of the matrix the dimensions of the transpose matrix changes. The original matrix is 2 by 3 matrix, and in the transpose matrix is 3 by 2 matrix. Let's do 3 more examples to understand what do you mean by transpose matrix. In this case, we are given a 2 by 2 matrix, so it's 2 minus 3 and 1, 1. So to transpose it, the row of the matrix becomes the column of the matrix. So hence we get this. So 2 minus 3 from row 1 on row one will become the column 1 element, and 1, 1, which is the row 2 element, will become a column 2 element. So the dimension will still be the same because the original matrix will have a 2 by 2. It's a 2 by 2 matrix. So hence the transpose matrix is a 2 by 2 matrix. Let's take a look at the second last example. 5, 10, 10, 5. This is also a 2 by 2 matrix. So by transposing it, the row 1 elements in the original matrix will become column 1 elements of the transpose matrix. So as you can see, 5, 10 here on row 1 will become 5, 10 on column 1, and 10, 5 on row 2 will become 10, 5 for column 2. And the dimension will still be the same. Now let's go through the last one, which is this. Notice that this is only a vector because it has only columns, one column. So we are given as a one column vector. So like, not to worry, it will be the same thing. So column 1 elements will become row 1 elements. Hence, it's written in this way. So column 1 elements become row 1 elements. And this time, the original matrix has a 3 by 1. It's a 3 by 1 matrix because it has 3 rows and 1 columns. So if we transpose it, it's a 1 by 3 matrix where it has 1 row and 3 columns. So this is the end of our linear algebra tutorial. In the next lesson, we'll be learning how to find the particular solution and the solution set of a homogeneous system in a system of linear equations based on the solution set that we actually did earlier on.